Daniel Bernoulli said, "It would be better for the true physics if there were no mathematicians on earth." But this is highly impossible to do physics without mathematics. In this video, we will learn how to calculate thickness of a given object by forming interference pattern due to air wedge. Generally, in Indian laboratories, the object used is a fine and thin wire or a human hair. So, these are the experimental readings corresponding to the hair, that is the interference fringes formed due to an human hair. So, these are the experimental readings and they are tabulated here. The first is the order of the fringes. For n fringes, that is for every 5 fringes, the readings are taken. The first column represents the main scale reading in the vernier microscope. The second one is the vernier scale coincidence. Look at the first reading here. For the nth fringe, the main scale reading is 5.05 and the vernier coincidence is 11. Now let's calculate vernier scale reading. The least count for the vernier microscope is 0.001 into 10 power minus 2 meters. So to compute vernier scale reading, we have to multiply vernier scale coincidence into least count. The vernier scale coincidence is 11 and the least count is 0.001. So the vernier scale reading is 0.011. So the total reading is calculated by adding the main scale reading and the vernier scale reading. The main scale reading here is 5.05 and the vernier scale reading here is 0.011. So the total reading is 5.061. See, for the n plus fifth fringe, the main scale reading is 5.10. The vernier scale coincidence is 8. So the vernier scale reading is computed by multiplying vernier scale coincidence into the least count. So it is 0.008. So the total reading here is 5.108. So that is got by adding the main scale reading 5.10 plus the vernier scale reading 0.008. In this way, we can find the total reading. Next is to find the width of 25 fringes. It is not necessary we should find the width for 25 fringes. We can go for 20 fringes or 30 fringes, or even you can go for the width of 5 fringes. Here I have computed for the width of 25 fringes. See, we have taken the readings from nth fringe to n plus 50th fringe in steps of 5 fringe. See, look at the color of the fringes. Since I have taken the width for the 25 fringes, I have highlighted the n and n plus 25th fringes in white color. So that means we have to subtract the nth fringe from n plus 25th fringe. That is 5.312 minus 5.061, which will give us 0.251. Similarly, the next the width for the 25th fringes comes from n plus 30 and n plus 5th ring, which are highlighted in yellow color, and the corresponding reading is 5.361 minus 5.108. So we got 0.253. The next 25 width is n plus 35 and n plus 10, which is highlighted in green color, and the next one is n plus 40 and n plus 15, which is highlighted in orange color. Then for n plus 45 and n plus 20, it is highlighted in blue color. So n plus 50 and and again it is n plus 25. Here I have not highlighted it in green color because it will overlap. So the last reading will be 5.560 minus 5.312, which gives out 0.248. So this column width of 25 fringes corresponds to the vernier reading for 25 fringes. So next we have to calculate what is bandwidth beta. Bandwidth beta. Actually our intention is to find the bandwidth here. So bandwidth, what is the bandwidth? It is distance between two consecutive dark fringes are bright fringes. So here it is, this is the width for 25 fringes, or here now the width for one fringe, that is the bandwidth is computed by dividing the 25 fringes by 25, width of the 25 fringes by 25. In case if you have found the width of 20 fringes, then you have to divide it by 20. If you have found it for 10 fringes, then divide it by 10. Okay, so I have found the width for 25 fringes. So to get the bandwidth, I am dividing my resultant by 25. If I divide 0.251 by 25, I will get 0.0110. 0.253 divided by 25 will give 0.01012. See, from my last table I could see my bandwidth beta remains constant. So I got 1, 2, 3, 4, 5, 6 bandwidth. So I have taken the average of the 6 readings. So the average, adding up all this 6 and dividing it by 6, beta is equal to 0.01005 into 10 power minus 2 meter. So now we got the value for beta. Next, L. We need L to get the thickness of the given object. So this is the readings corresponding to the distance between the given object and the tied end of the glass plate. So first reading corresponds to the reading of the object. The second one is the reading corresponding to tied end. In the same way, we got the mine scale reading, vernier scale coincidence, and vernier scale reading. The vernier scale reading is calculated by multiplying vernier coincidence with the least count. See, it is the main scale reading is 3.50 and the vernier scale coincidence is 21. The vernier scale reading is computed as vernier scale coincidence into least count, that is 21 into 0.001. So we got 0.021. So the total reading is obtained by adding the main scale reading and the vernier scale reading. So it is 3.50 plus 0.021. So we got 3.521. The next reading for tied end is also calculated as 6.485. So to get L, the difference between these two readings will give you the L. So the difference between these two readings is 2.964 into 10 power minus 2 meters. Now let us calculate. The formula used to calculate the thickness of the given object is lambda L by 2 beta. Here the lambda is nothing but it is the wavelength of the monochromatic source used. The source used here is the sodium vapor lamp, and the wavelength corresponding to that sodium vapor lamp is 5893 into 10 power minus 10 meter. And L, the length 2.964 into 10 power minus 2 meter. The beta, the bandwidth is 0.01 into 0.005 into 10 power minus 2 meter. So putting everything, we get 5893 into 10 power minus 10 into 2.964 into 10 power minus 2 divided by 2 into beta value 0.01005 into 10 power minus 2. See the powers. Okay. Next, let us multiply this numbers. 5893 into 2.964 will give you 17466.852 divided by 0.0201. So I have clubbed the powers here. This 10 power minus 2 and 10 power minus 2 will get cancelled. The remaining power is 10 power minus 10. The dividing these two numbers will give you 868,997.611 into 10 power minus 10. So I am pulling the power inside. So I'm pulling 4 powers inside, that is minus 4 powers inside. So I get 86.8997 into 10 power minus 6, because the thickness of the object which I have used is measured in microns. The thickness of the hair is measured in microns. So I have brought that power to 10 power minus 6. So the thickness of the object, the given object, that is for a human hair, the thickness is found to be 86.8997 into 10 power minus 6 meters, or 86.8997 micron meter. 10 power minus 6 can be written as micron meter. Generally, the thickness of the human hair lies between 80 micron meter to 120 micron meter. So this is the expected